Hello, today I'm going to lecture about the geocentric and heliocentric models. These are the topics for today. We're going to first look at what science actually is and how to identify when you're looking at one. Then we're going to discuss the geocentric and heliocentric models. Then we'll compare that to science and discuss if and why these models fall into the area of science. Then we'll discuss what version of these two models we use today. So there are three areas of science which I will define for you. First is just good plain old science, then proto-science, then pseudoscience, then non-science. So starting with science, science is the intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through the observation and experiment. So we're going to talk about first Francis Bacon, born 1561, died 1626. He was a 16th century philosopher who heavily promoted the scientific method and brought it to fruition amongst the scientific world. The scientific method is what is standard today and is what is used amongst all who wish to solve a problem. It consists of identifying a problem that is observable, developing an initial hypothesis, gathering additional information and refining the hypothesis, then finally testing that hypothesis, and then evaluating the results of the test that you did on the hypothesis. If your hypothesis turns out to be correct, fact, then you're going to publish your results. Obviously, you're going to tell everyone about it. But if you were incorrect, you find that your hypothesis was false, you're going to go back to step 2 and develop your hypothesis again, refine it. Now, when it comes to science itself, we can recognize it by its hallmarks. So those are natural, observable, testable, tentative, uncertain, and social. So when we're talking about a natural occurrence, we're just talking about something that happens within nature, a mechanic of nature, something like gravity, or I guess the stars in this case and the way they move about. Something that is observable, so something that we can observe with our senses, something we can look at or hear or feel. And then we have to be able to test this thing that we've observed. If we can't test it, then there's no point. And then it has to be tentative, meaning what you find has to be subject to change. The information that you're looking at, your discoveries about it, your opinions might change as you find out more information. And then you're always uncertain. There's never 100% certainty when you're in science. You're always trying to find out more information. And then social. You need to converse with your colleagues and whatnot and discuss your results and compare, contrast what you guys have found. So, proto-science. Proto-science is a field of study or instance that is initially not scientific, but becomes scientific through subjection to tests. Examples of proto-science are, say, aliens, speed of light travel, scientific or sentient artificial intelligence. Currently, all three of these examples do not adhere to all the hallmarks of science, specifically observable and testable. We can't exactly observe aliens or, in that matter, test that they exist. We cannot observe traveling at the speed of light. We can't observe or test sentient artificial intelligence. But if we were to discover them, we could apply all the hallmarks of science, which would then make them science. So some examples of that, someone like Sir Francis Bacon probably didn't have access to information about solar power or combustion engines or climate change. Those would have been proto-sciences in his day, but now through further testing and advancement in technology, they are now science. So stuff like that. Now, it's not science yet because They are not observable or testable. That's the difference between proto-science and then just regular science. But maybe one day they will be. So then we have pseudoscience, a collection of beliefs or practices mistakenly regarded as being based on scientific method. So some examples are like Bigfoot, or I have Chupacabra here, or some practices are like astrology, you know, like your astrological sign, or mediums, people that have this gift to talk to the dead, sidekicks, people that can tell your future. Not science, because practices do not identify with the observable and testable hallmarks, and scientific method was not used to support any conclusions that were made within these practices. So basically, with the three on the left, it's kind of personal experience. You know, you can't really observe or test. Usually only evidence that these people have for their the pseudoscience they practice is, oh, you know, I saw Bigfoot and I saw him. Now I'm going to look for him. Or, you know, oh, this astrology sign, it's so like me. You know, you can't really test or observe that. At least other people can't. So, and also the difference between pseudoscience and protoscience is that that very same thing I just said, the personal experience. The protoscience is something that can one day be testable and observable. But however, things like astrology, you can't really test or observe the way the universe was oriented, how that affects your personality. It's just not something that's true. So finally, we have non-science, and that's information that is not proven to use scientific methodology or observations. So, for example, pit bulls are more dangerous than other dogs. Obviously, by my picture in the bottom left, that's completely false. Another good example, the COVID-19 vaccine has GPS trackers in it so that government can track your location. Also, by the way, there are more spiders on Halloween than there are on any other days. So these things are just pure conjecture and opinion. Or again, I might feel that I've seen more spiders on another day. With that, we are equipped to put ourselves in the shoes of our ancient astronomy ancestors and talk about the geocentric and heliocentric theories. Here's their definitions here. But first, we're going to talk about the geocentric model, which is a cosmological model of the universe which puts Earth at the center of everything and depicts everything revolving around Earth. So, although the theory existed long before him, Claudius Ptolemy was responsible for creating the most advanced, and detailed model of the geocentric theory of the universe. Ptolemy had an extraordinary observatory in Alexandria, Egypt, and there he attempted to answer a mystery which was proposed by the apparent backtracking of Mars through the sky. Mars was and is still moving in a way which is called retrograde motion. Mars, due to its longer orbit around the sun, appears to backtrack in its revolution for a short while before resuming on its former path. It looks like a bit like this. Looks a bit like that. On the left, we observe the revolutions of Earth and Mars around the sun. And on the right, we can observe the perceived backtrack and Mars's trajectory before it continues back on track. Ptolemy was attempting to explain this phenomena with his quite complicated version of the geometric model. Ptolemy's model illustrated in the bottom right corner. Mars revolves around the Earth, and it's deferent and simultaneously revolves around a central point along the deferent. This smaller revolution is called an epicycle. In this illustration, this retrograde motion model would have caused the same effect as the true model, which I showed you previously. So to recap, Ptolemy's model accounted for retrograde motion, accurately predicting the location of celestial bodies for almost 1,000 years, or over 1,000 years, and used a geocentric model. Again, this is an illustration of how Ptolemy's model would have created the same motion as this model here. And this model is a heliocentric model. You can see that the blue is Earth and the red is Mars, and it's going around the sun. And the heliocentric model is a cosmological model of the universe, which puts the sun at the center of everything and depicts everything revolving around the sun. Nicholas Copernicus was born more than a millennium, 1,000 years after Ptolemy. And like him, the heliocentric model existed long before him. But it was during a convergence of a lot of the celestial bodies in our solar system in the constellation Cancer that Copernicus discovered that Ptolemy's predictions of celestial bodies and where they would be was incorrect. So he found out that Ptolemy was wrong, and he wanted to create or discover a new model. So Copernicus hypothesized that the universe had a heliocentric orientation, meaning everything in the solar system revolved around the sun. And he also hypothesized that the planets were within our solar system, or at least they were closer, and that the stars were very, very so distant and far away. Copernicus hypothesized that the universe had a heliocentric orientation, and the heliocentric illustration I used first to explain retrograde motion was created by Copernicus. He said that retrograde motion was caused by Mars's longer orbit. Because Mars's orbit is wider and takes a longer path, Earth in its revolution catches up and passes Mars, as we saw in this illustration here. We can look at positions 1 through 5. We can see how that would take place. So Copernicus's model explains the same thing that Ptolemy's model did. The difference is that Copernicus's model was simpler. It did not involve random and unexplained center points of revolution. As we can see here, this black dot in the epicycle is just, there's nothing there. It's just revolving around nothing. Or at least so they hadn't discovered anything there. So with everything orbiting around the sun, that was taken away. No unexplained points of revolution. It also did not involve as many moving parts, if you will. Each planet revolves one way around the sun. So there wasn't a bunch of, difference and then epicycles going. It was just one revolution. So unfortunately, Copernicus' model did not predict the location of the celestial bodies any better than Ptolemy's model. This is due to the Greek tradition of assuming orbits have are a perfect circle instead of the shape of an elliptical, which is what is true. So to recap, Copernicus' model predicted locations of celestial bodies, more simple, and explained retrograde motion, more simple. It also did away with the mysterious central points of which the revolutions were fixed, the difference in the epicycles. He had many people that disagreed with him. Some of the points that they made against his model were that if Earth was moving, why didn't they feel the motion? This was before they found out about gravity. So they didn't feel the motion. If the Earth was moving, then the air on the Earth would be, blowing them off their feet. And also, if the Earth was moving, there would be also seasons of brightness with stars. if we were revolving on one side of the sun, we'd be closer to the stars on that side. And if we're on the other side, we'd be closer to the stars on that side. And the rebuttal to that was that those are just so far, the stars outside the solar system are so far away that really just moving what we know now to be 100 million, 150 million kilometers doesn't make any difference whatsoever. So where does this all tie into science? How does it compare to all the hallmarks and the scientific method? Well, firstly, both models were put through a 3,000 plus year ringer of the scientific method, so both were all well tested. Okay, we know that. But when we apply all the hallmarks to the methods, they both attempt to explain a naturally occurring phenomena, the movement of the cosmos. Excuse me. They both are observed with the motion of the night sky, meaning that they can look with their eyes, one of their senses, and they can see what's happening. And they're both testable just by simply doing the same thing. In this case, observing is also testing, because now we have simulations we can just run and skip a year to see where things are, but they had to wait. So waiting for them was observing to see how their models put up against time. Is how they found out Ptolemy's model was incorrect. Both have changed and evolved over the course of the millennia, back and forth on the heliocentric and geocentric models. Before Ptolemy, there was a different conclusion, unexplained things, then Copernicus came, so there was a lot of change. And the entire world of astronomy was uncertain about both the models. That's why there was all this debate. No one actually knew what was going on. And then finally, astronomers were able to socialize and debate these models over a long time. Thousands of years they've been conjecturing what everyone thinks. So both models meet the specifications of the hallmarks. But how do these ancient theories compare to what we know today? Well, today, as I'm sure you know, the heliocentric model is correct. Is correct, and Copernicus was right about retrograde motion. Today, we now know that orbits take an elliptical path, which is more oval shaped opposed to a perfect circle. This information allows us to now predict accurately the positions of the celestial bodies. Although the heliocentric model is the correct depiction of the solar system, we still use the geocentric model in the form of the celestial sphere. As it turns out, making yourself the center of everything and using yourself as reference makes it a lot easier to navigate a place where there are no ups, downs, lefts, rights. So although the model itself is not in use, its spirit lives on while we continue to map the known universe. Thank you very much.